In this video, we will be discussing about first partial ordering relations, right? So suppose there is a relation R on set A. This is called partial ordering or partial order. If it is one reflexive, second antisymmetric, and third transitive, right? And if a set A together with a partial ordering relation R is called ordered set or poset and is denoted by A, R, members of A are called elements of posets. So set A members right. Suppose I have to prove, there is a question, prove greater than or equal to relation is partial ordering set on integers, right? So suppose A belongs to Z, right? And A is greater than or equal to A. So this is reflexive, right? And then if A comma B belongs to Z, right, A is greater than or equal to B, B is greater than or equal to A, but here A is equal to B, right, because A comma B belongs to R, B comma A also belongs to R, and A is equal to B. So this is antisymmetric, and now we have A greater than or equal to B, B greater than or equal to C. So A will be greater than or equal to C. So this is transitive, right? This symbol is transitive relation. Now we will discuss about hash diagram. So what is hash diagram? It is simplified drawing of partial order. So there are three rules of hash diagram. First is removing of self loops, right? Elements that are relating to themselves, we have to remove them. Then we have to remove arrows implied by transitivity, right? Arrows implied by transitivity. Suppose I have 1, 4, 4, 2. So I don't have to make arrow for 1, 2, right? And then remove allow arrow direction. So arrow direction, if A is below B, so there is no need of making arrow, right? Now suppose I have to make a hash diagram. So I have to make, suppose for A comma B, right? A divides B and set on set 1, 2, 3, 4, 6, 8, 12, right? So what I will do, I can make it like this: 1, 2, 4, 8, and then 3, 6, 12, right? I can make it like this, and I can give arrows. So 2 is divisible by 1, 2 is divisible by 4, 8 is divisible by 4, 3 is divisible by 1, 6 is divisible by 3, 12 is divisible by 6, and 4 is divisible by 1, 8 is divisible by 1, 2 is divisible by 8, right? And 3 is divisible by 12, 12 is divisible by 3, 6 is 1 is also divisible by 12, and 1 is divisible by 6, right? This is what you can write, and all are divisible by themselves, right? So the modified hash diagram will be 1, 2, 3, 4, 6, 8, 12, and this will be like this. This arrow will point here and this arrow will point here, and nothing else is required, right? Now let's solve another question. Now suppose I have for set A comma B, right, and A is subset of B, right, on power set PS, right, where S is A comma B comma C, right. So power set will be what? This will be A, right, B, then C, then AB, then BC, then AC, then A, B, C, and then 5, right. So accordingly hash diagram will be 5 on below, then A, then C, and then AB, then BC, then AC, and at top A, B, C, right. So this will be like this. This is going here, this is also going here, this is going here, right, this is B, and this is going here, right. So in this way the hash diagram can be made. Now we will discuss about maximal and minimal elements. So, right, so then we are discussing about maximal and minimal elements. Let me erase here. Yes, so maximal elements are those elements if suppose there is an element A and that element is maximal if there is no element B in the poset such that A is less than equal to B, and minimal element, suppose an element A is minimal if there is no element B such that B is less than equal to A, right. Now greatest element, maximal element, that is unique, right, every element is less than equal to it, and least element is minimal element that is unique and every element is greater than equal to it, right. So if maximal and minimal elements are unique, then they are greatest and least elements respectively. Now suppose for poset 2, 4, 5, 10, 12, 20, 25, right, and for what I have to find? A divisible by B, right. So first how I will make hash diagram, first see 4 is divisible by 2, right, then 10 is divisible by 2, 12 is divisible by 2, 20 is divisible by 2, right. So in this way I will make, and then 12 is divisible by 4, 20 is divisible by 4, then what I will write? 10 is divisible by 5, 20 is divisible by 5, 25 is divisible by 5, and then 20 is divisible by 10, right. So now I can see 2, 4, and here it is going 4, 12, so it is transiting, so I will remove this one, and then 2, 4 it is going and 4, 20 it is going, so I will also remove 2, 20, that is this, right. Right. Now also okay, right. Now there are 2, 4, 2, 10, 4, 12, 4, 20, 5, 10, 5, 25, right, 5, 20. So okay, so 10 is divisible by 5 and 20 is divisible by 10. So I will also remove this one. Right. Now what I will do, I will get my list value here 2, 5 and then one level above, right? 4, then 10, then 25 and then one more level above 12 and 20, right? So now I can make accordingly like this, right? So this is given as this, right? So maximal elements are 12, 20, 25 and minimal elements are 2 and 5, right? Now what is upper bound and lower bound? So upper bound of A means an element U belongs to S such that A is less than equal to U for every A belongs to capital A. It is greater than or equal to all elements of A. And lower bound of A is an element belongs to S subset such that I is less than equal to A for every small a belongs to capital A. It is less than or equal to all elements in capital A, right? Now we will discuss about least upper bound. So a smallest of all upper bounds, also called supremum, unique if it exists, x is equal to least upper bound A if x is an upper bound of A and x is less than equal to capital Z for every upper bound Z, right? And greatest lower bound is largest of all lower bounds and unique if it exists Y, GLBA if Y is lower bound of A, right? And Y is greater than or equal to Z, right? Now we will go into the next topic, recurrence relation. So a recurrence relation for a sequence AN is an equation that expresses AN in terms of one or more previous term, right? Suppose I write AN as 3 AN minus 1, or I write this as AN as AN minus 1 minus AN minus 2. So this is a Fibonacci example, right? Now types of linear recurrence relation. So if I talk about homogeneous, then it will be given as AN is equal to C1 AN minus 1 plus C2 AN minus 2 up to CK AN minus K, right? This is homogeneous. And for non-homogeneous, it can be given as the same thing, only difference is there will be function added here, right? Plus here it will be an extra function, right? Suppose Fn can be n square or something, right? This is for non-homogeneous, right? So let's see how to solve homogeneous recurrence relations, right? So let me erase this. So now solving homogeneous linear recurrence relation. So suppose there are distinct roots, right? All roots are different. So suppose there are distinct roots R1, R2 and Rn. So An will be given as, alpha 1 R1 to the power n plus alpha 2 R2 to the power n up to alpha k Rk to the power n, right? And if roots are repeated, right? Suppose R1 is equal to R2 is equal to R. So An will be given as alpha plus beta n, right? R to the power n, right? If there are three equal roots, right? Suppose R1 equal to R2 equal to R3 equal to R, then it will be given as alpha plus beta n plus gamma n square r to the power n, right? So let's solve a question. Suppose I have given as an is equal to an minus 1 plus 2 an minus 2, a0 is equal to 2, a1 is equal to 7. So what I will do, right, I will write this as Rn equal r to the power n is equal to r to the power n minus 1 plus r to the power n, right, minus 2 r to the power n minus 2, right. So this will be simplified as r square minus r minus 2 equal to 0, right. So the solutions are r is equal to 2 comma minus 1, right. Now roots are distinct, so general solution will be given as an equal to alpha to the power n plus beta minus 1 to the power n, right. So a naught is equal to 2, so this means 2 is equal to alpha into 1 plus beta into 1. So alpha plus beta is equal to 2, and then 7 is for what? A1 is equal to 7. 7 is equal to 2 alpha minus beta. So 2 alpha minus beta equal to 7. So accordingly we can get alpha and beta, right? And we will substitute in it original. So answer we will getting is 3 into to the power n plus minus 1 to the power n plus 1. Now let's discuss on next question. Suppose I am given as, it is given as an is equal to 6 an minus 1 minus 9 an minus 2 and a0 is 1, a1 is 6, right. So it will be written as r to the power n, 6 r to the power n minus 1 plus minus 9 r to the power n minus 2, right. And this will then written as r square minus 6r plus 9, and the solution will be r is equal to 3 comma 3 repeated root. So the generalized answer will be given as an is equal to alpha plus beta n whole into 3 to the power n, right. And alpha is equal to 1, so it will be for 1 is equal to alpha plus 0 into 1, right. Alpha is equal to 1, and then a1 is equal to 6, so it will be written as 6 is equal to 1 plus beta into 3, so beta will be 1. So answer will be given as an is equal to 1 plus n into 3 to the power n, right. This is how we will find the solution of recurrence relations, right. So this is all for today.